Hey everyone, I'm Ramya, a developer advocate for AI and open source at NetApp InstaCluster. In this video, we are going to break down OpenSearch KNN vector field type, what it is, why it matters, and you'll see it running live on an OpenSearch cluster. Quick note before we start. If you're new to OpenSearch itself, check out the basics videos on this channel first. Let's get into it. When someone searches how do I fix a slow computer, they do not want pages with that exact phrase. They want articles about performance, troubleshooting, and optimization. Keyword search alone cannot do that. You need a semantic layer. That is what KNN vector gives you. It is OpenSearch field type for storing vector embeddings, numerical representations of meaning. You convert your content into numbers using a machine learning model, do the same for the search query, and OpenSearch finds the closest matches. That is semantic search, and KNN vector is what makes it possible at scale. When you define a KNN vector field, there are 4 parameters worth knowing about. You can see them on screen now with their defaults. Space type is Euclidean distance, engine is Facebook AI similarity search, method is hierarchical navigable small world, and data type is float. The defaults work well for getting started, and you can override them for production. One more thing, you will also specify a dimension, and this has to match the output size of your embedding model. If your model produces 384 dimensional vectors, your index has to expect 384. They cannot mismatch. Alright, let's see it in action. I'm using an OpenSearch cluster on NetApp InstaCluster managed platform. There is a video linked in the description that walks through how to set one up. When you provision the cluster, make sure to enable AI Search plugin that automatically activates the KNN plugin we need. Let's head into OpenSearch Dashboards. I'm inside the DevTools console. 3 things to do: create a vector index, index a document, and run a semantic search query. First, the index. This is the command to create the index. Here, we set index.knn to true. Without it, KNN vector will not work. We define an embedding model of type KNN vector with dimension 4. Real embedding models produce 384 to 1536 dimensions. But for this demo, 4 is fine. I have not specified the other parameters, so OpenSearch will apply the defaults we just talked about. Now let's run the command. Here we could see that in the output, index is created successfully. Next, let's index a document. This is the command to index the document. Here, we are posting a document with a text field and a 4-number embedding. In production, you would not write these numbers by hand. You would pass your text through an embedding model. The Sentence Transformers Python library is a popular one. One critical thing: use the same embedding model for indexing and querying. Different models produce incompatible vectors, and your search will quietly stop working. Now let's run the command. Here you could see in the output, the document is indexed successfully. Now the third step, the fun part, which is to run a semantic search query. This is the command to run a semantic search query. Here we pass in a query vector that is close to but not identical to the embedding we indexed, and ask for the top 5 nearest neighbors. We are not looking for an exact match, we are looking for the closest semantic match. Now let's run the command. Here, OpenSearch returns our document with a similarity score. A higher score means a closer match. That is our semantic search pipeline end-to-end. 3 quick takeaways. 1. KNN vector is the field type that enables semantic search in OpenSearch. 2. The defaults work well for experimentation, but in production, explicitly define your parameters to match your embedding model. 3. The workflow is always the same. Create the index, index documents with embeddings, and run KNN queries. If you want to go deeper, the full blog article is linked in the description. And if you want to try this yourself, spin up a free OpenSearch cluster on NetApp InstaCluster. That link is also below. If this was helpful, give it a like and subscribe. Thanks for watching.